This video will show you how to factor trinomials in the form ax squared plus bx plus c. We're going to have a coefficient right here in front of the x squared, and that coefficient will not be a greatest common factor. So here's a 2 that's a coefficient. It is not a GCF. So this changes our factoring technique, and here's a nice little trick. I'm going to draw an arrow here because I'm going to make a new trinomial. This new trinomial is not equal to this old trinomial. I'm just going to kind of pretend something for a little bit so that we can get on our way of factoring. So what we do is we ignore the 2 for a second and we just write x squared plus 7x plus, now what the last term is that 2 that we ignored a second ago times that 3. 2 times 3 is 6. Notice in this trinomial we no longer have a coefficient in front of x squared. This is a much easier polynomial to factor. This is one of these where we just have to build our two binomials. We know it has to be xx. We know the signs must both be plus. And what we're saying here is give me two numbers that multiply to give me 6, that add to give me 7. That would have to be 6 and 1. So this is the correct factorization for this blue polynomial. But remember, we ignored this 2. Well, what we do to get the 2 back involved is we divide both of these numbers by 2. You could kind of think of it this way. We multiplied by 2 to create this new polynomial. So we've got to go backwards now and divide by 2. Well, in this binomial, 6 divided by 2 comes out even as 3. But over here, 1/2 does not divide out any further, and what we do is we take that 2 denominator and we put it in front of the x to give us this binomial, 2x plus 1. And if we FOIL this up, we will get 2x squared plus 7x plus 3. So x times 2x is 2x squared, x times 1 is x, 3 times 2x is 6x, and 3 times 1 is 3. If you put x plus 6x together, that's your 7x, and that is that polynomial. So this is just a little trick for being able to factor this kind of polynomial. So let's look at a couple more so you get the process. So we're making a new polynomial. It is not equal to the old polynomial. We drop the 2 for a minute, and we just use x squared plus 7x. And what is our third term is 2 times 6, which is 12. Now, being able to finish this polynomial relies on you being able to factor easy trinomials. And you can look back in Blackboard and see the 2 videos previous to this are factoring easy trinomials. So if you didn't quite master that, go back and look at those videos. So xx, both of the signs are positive in this case. And what we are saying is what multiplies to give me 12, that adds to give me 7. Well, your factors of 12 are 1 and 12, 2 and 6, 3 and 4. So 3 and 4 are the 2 that add to give you 7. So 4, 3. And you know it doesn't matter if you put the 4 here and the 3 there or vice versa. So now we go back and we get this 2 involved. We had already multiplied by the 2, so we need to come back and divide by the 2. Divide both of those numbers by 2. And 2 different things happen. In the first parentheses, 4 divided by 2 is 2, and we're finished with that. But over here, 3 does not divide evenly by 2. The fraction does not reduce. So what I do is take that 2 and I slip it in front of the x. And now it becomes 2x plus 3. And if you FOIL this out, you will get the polynomial 2x squared plus 7x plus 6. Same kind of problem. We're going to ignore the 3. So my new pretend polynomial is x squared minus 14x plus 3 times 8 is 24. Now this one's a teeny bit different than the last couple because of the signs. Because the last sign is positive, we know these two signs are the same, and what they're the same as is the middle sign. So they're both minus. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and the pair that adds to give me 14 will be 2 and 12. You may not need to make this list of factors. You may know right off the bat what multiplies to give me 24, that adds to give me 14 is 2 times 12. If you don't know that right off the top of your head, then you need to make a list of the factors and find the pair of factors that will give you the correct middle term. We're not finished here. We've got to go back and take this 3 and divide both of these by 3. In this parenthesis, 2/3 does not reduce. It doesn't come out even, so I need to slip this 3 in front of the x and get 3x minus 2. In the second parenthesis, 12 divided by 3 comes out nice and neat as 4. And there's your factorization, and I hope you remember that it doesn't matter what order this is in. X minus 4 could be in the front, and 3x minus 2 could be in the back. Ignore the 2, and we have x squared minus 9x plus 2 times 9 is 18. This is the same sign configuration as the last one. Since the last sign is positive and the middle sign is negative, these are both negative. And we are saying what multiplies to give us 18 that adds to give us 9 would be 6 and 3. So there's the factorization of our pretend polynomial here in red. Let's come back and get this 2 and divide both of these numbers by 2. I mean, 6 divided by 2 comes out even as 3. Over here, there's nothing I can do with the 3/2, so I've got to take that 2 and slip it in front of the x. This is not your standard way that you probably learned how to factor these trinomials, but it is a neat little easy trick that relies on you knowing how to factor that kind of polynomial. 6x squared minus x minus 12, we're going to drop the 6. Our new pretend polynomial is x squared minus x minus 6 times 12 is 72. Parentheses has to be x. Now, because this last sign is negative, we know that the signs are different. And I teach to put whatever that middle sign is in the front, and if the signs are different, that means this must be positive. And now, because the signs are different, you are saying to yourself, what multiplies to give me 72 that subtracts to give me 1? It might be a good idea to pencil in that little 1 right there. Because the signs are different, it becomes what multiplies to give you 72 that subtracts to give you 1, because these are different signs. Different signs take the difference. So what works is 9 times 8. Because we have put the middle sign in the front, we will put the bigger number in the front. Didn't have to worry about that when both signs were negative or both signs were positive. But when one sign is negative and one sign is positive, if you follow this rule and put the middle sign in the front, then you can put your bigger number in the front. And if you FOIL that out, you will get x squared minus x minus 72. We still have to come back and deal with this 6, divide both of these by 6. This is the first time this has happened. We need to reduce these fractions before we go any further. So 9 divided by 6 reduces to 3/2. 8 divided by 6 reduces to 4/3. You must reduce the fractions before you continue. Now I can slip that 2 in front of the x, and this becomes 2x minus 3. Slip the 3 in front of x, becomes 3x plus 4. If you FOIL that out, you will get the original polynomial. Dropping this, x squared minus 7x plus 6 times 2 is 12. Think about what your signs are going to have to be. X. Since the last sign is positive, we know the signs are the same, and what they're the same as is that middle sign. So these are both minus. And what multiplies to give me 12 that adds to give me 7, it is add again because these signs are the same. Same signs sum would be 4 and 3. Let's get that 6 and divide both of these by 6. Reduce those fractions. 4/6 reduces to 2/3. 3/6 reduces to 1/2. And if you're not very good with reducing fractions and you have a calculator, most scientific calculators will do fractions for you. You can type that in and let it do the reducing for you. All that's left now is to slip this 3 in front here, and this becomes 3x minus 2. And this becomes 2x minus 1. And that will FOIL and check out to be your original polynomial. Bigger numbers, but this still works. I am making my pretend polynomial, which is x squared minus 17x plus 12 times 6 is 72. What are the signs going to be? Since the last sign is positive, I know the signs are the same, and what they're the same as is the middle sign. So these are both minus. And because they're both minus, you are saying what multiplies to give you 72 that adds to give you 17. And this might be one that you might want to write out a list of factors. So 172, that doesn't give me 17. 2 and 36, that doesn't add to give me 17. 3 and 24, nope, that doesn't give me 17. 4 times 18, no, that doesn't give me 17. 6 times 12, that doesn't give me 17. 8 times 9, and there we go. 9, 8. And then divide by your 12. Reduce those fractions. That reduces to 3/4. This one reduces to 2/3. And then we got to go back and take care of that coefficient here. Slip that in front. It becomes 4x minus 3. Slip this one in front, becomes 3x minus 2. And that is your factorization for the original polynomial. All right, ignoring our 6, x squared minus 19x plus 6 times 10 is 60. Signs here will both be minus. And you're saying what multiplies to give you 60 that adds to give you 19. You might need to make a list, but what works is 15 and 4. Because 15 times 4, technically, negative 15 times negative 4 is what gives me positive 60. And negative 15 plus negative 4 gives me negative 19. Come back and divide each of these by the 6. Reduce your fraction. Gives you x minus 5/2. X minus 2/3, and then just slip that coefficient back in front. Put the 2 in front here. 2x minus 5. Slip the coefficient in front. 3x minus 2, and there's your factorization. Now, what you need to remember is that the number one kind of factoring you're supposed to look for is to take out the GCF. I purposely made all the previous examples not have a GCF so I could just teach you this new technique. But you have to put it all together and look for a GCF to begin with. If your lead coefficient is negative, your GCF needs to be negative. And besides that, we have a 2 that goes into all of this. So we're going to divide everything by negative 2. And if it helps you any, pencil in a little negative 2 underneath each one so that you get your signs right and do your arithmetic right. So negative 12 divided by negative 2 is 6, x squared. 22 divided by negative 2 is negative 11. 4 divided by negative x. 4 divided by negative 2 is negative 2. What I suggest you do is you put negative 2 here, and you draw your 2 parentheses, and then you go over somewhere else on your paper to do the rest of the problem. I'm afraid that you're going to drop off the GCF. So I always say, write this down with the 2 binomials here, then go over to the side, just using this part right here now, because we took out the GCF. That's the polynomial we're working with. So our pretend polynomial here is x squared minus 11x, because we dropped the 6, but 6 times 2 is 12. So here's our new pretend polynomial to factor. Because the last sign is negative, that tells you that your signs are different signs. Notice I put the middle sign in the front. Now I'm saying what multiplies to give me 12, that subtracts to give me 11. The reason I'm saying subtract is because these signs are different, and that has to be 12 and 1. I didn't leave enough room there, so I'll rewrite this. This is x minus 12, and this is x plus 1. And that will FOIL up to give me x squared minus 11x minus 12, but I'm not finished. I need to still come back and get that 6 and divide both of these by 6. The first parenthesis comes out even. 12 divided by 6 is 2, so that's good. Over here, the fraction 1 over 6 doesn't reduce any further, so we're going to slip that coefficient in front of the x, and we have 6x plus 1. And we're still not totally finished. Remember, we laid out our answer over here with this GCF we took out, so we need to send this stuff back over here. So x minus 2, 6x plus 1. And that, including the negative 2, is the complete factorization.